Hello, today I'll be showing you how to make polynomial and rational functions from looking at a graph. In problems 51 through 54, find a rational function that might have this graph. More than one answer might be possible. So today we're going to be doing problems 52 and 54. So in order to find your function, you need to look at the dashed lines on the graph. Those are going to represent your vertical asymptotes due to them being dashed and going across the x-axis. So let's begin. The first thing you want to do is you need to find the denominator. And like I said before, you need to look at the dashed lines. So your formula should end up looking like this for the denominator. A into x divided by x plus 1 parentheses x minus 1. The reason why we have x plus 1 and x minus 1 is due to the dotted lines being passed through those points. But instead of putting minus 1, we're going to put plus 1, and instead of putting plus 1, we're going to be putting minus 1. And as you look at it, these represent your vertical asymptotes. Now, the next thing you need to find are your zeros so that way you can multiply by a. In order to find your zeros, you have to make sure that your x equals 0. So therefore, the only time that our x represents 0 is when it's passing through this blue line. See how solid it is? That lets you know it's a great variable. So next thing we're going to do is we're going to estimate where it's going to be. And by looking at the graph, it is at 0.25 due to it being below 1. So our numerator is going to be a equals to x minus 0.25, or also known as 1/4, equals to x plus 1 x minus 1. Since the dashed lines crosses the y-axis along with the blue lines, that means that the multiplicity is positive. Next, you have to find your horizontal asymptote, which has to be bigger than the denominator. So, like we said before, since we got 0.25, we're going to change that and put that as a negative 1/4 because we're trying to cancel this one out. So you're going to end up having negative 1/4 equals to a times 1/4 over 1 times negative 1. Then you multiply these at the bottom. So when you multiply your denominators, you're going to end up equaling a equals to 1/4 into negative 1. Which means, and since these two will cancel out, you can just go on and cancel them out. Which means a equals to negative 1. Which means our function equals to negative 1 x minus 1/4 x plus 1 and x minus 1. If you want to make sure that you're correct, you could go to an online calculator and it will show that this represents this graph. And what I failed to mention was that up here, x equals to negative 1 and x equals to positive 1. That's why whenever you do your work, you're going to change that first variable into a positive and your second variable into a negative, so that way they can cancel out. Now, let's work on problem number 54. Okay, you can pause it. Okay, Now let's take what we learned from problem 52 and work on problem 54. Like I said before, these dashed lines represent our vertical and horizontal asymptotes. But as you notice, we have an extra line. But this time it's going in the horizontal direction, which means we are going to have our horizontal asymptotes. So let's begin. So, like I said before, in order to find the equation, you need to find the denominator first. So, put a into x, divide that by x, x plus 3, x minus 4, x minus 3. And I'll mention to y'all why I have x plus 3, minus 4, and minus 3 in a second. But let's find our numerator. Now remember how I said we need to find our zeros? As you notice, our graph touches a 0 right at 0. So instead, we are going to have 0 equals to a times 0, which means it's going to equal to 3 times negative 4 times negative 3, which means let's go on and solve the denominators. So 3 times a negative 4 equals to negative 12. And negative 12 minus a negative 3 equals to 36. So instead, we're going to have 0 equals to a over 0 over 36. But remember, every time you have a 0 as your numerator, that's automatically going to change it to 1. So we know now that our 1 is a. And remember, cross out your zeros since they cancel out. So now our equation is going to be 1 equals to x minus 0 into x plus 3, x plus 4, and x minus 3. The reason why we have three numbers as our denominators is as mentioned up here, we have a horizontal asymptote, and just like vertical asymptotes, they're going to represent our denominators. And as you see, our y equals to 3, and then our x is equal to negative 3 and plus 4. Now remember, when the number is negative, you change it to a positive. And when the number is positive, like these two, you change it to a negative. And that's all for our video. I thank you for watching.